Hello guys, let's find the three ways to solve this integral right here, 1 by 1 minus x squared. Now, I've given you guys three hints for the three ways to solve it. Now, for the first one, have some blank please. Well, I'm sorry this hint was not that very obvious, but it is standards. Have some standards, please. Well, if you were thinking food, not your fault, I guess. Now, for the second method, these scam networks will only take a blank of your money. Well, it's I think more obvious than the first hint, but it's a fraction. Because we're going to be using partial fraction for this. And for the last one, well, you have to guess what this is. This drawing, hopefully it's good. If not, I'll try to improve. So I wished I had a red pen because it would have made it more obvious. But this is the coach or was just a substitution board. So there I said it, substitution board or substitution method. So for first one, oh I forgot to say, for the first one we're going to be using the standard formula. So if we have the integration of dx by a square minus x square, its standard formula is 1 by 2a log natural of a plus x by a minus x plus c. And right here, a we have 1, so instead of a we have 1, so simply this is 1 by 2 into 1, which is just that, log natural of 1 plus x by 1 minus x plus c. So there we go, that is the first method. Now for the second method, we're going to be doing partial fraction. So let's factorize the bottom part, which is just 1 minus x into 1 plus x. Alright, 1 minus x, 1 plus x. So this is going to be 1 minus x plus 1 plus x dx, and we're going to have to solve for the numerators. So I'm going to be using the cover-up method, but you can also use a and b, multiply them out, and then equate the variables and constants. So to find the coefficient of this, you cover up the factor, which is 1 minus x, and then you ask yourself, how do you make this equals to 0? Or so for this one, x has to be equals to 1, and the value of x you put it in the other factor, which is 1 plus x, which becomes 2. Technically it, so in fact it's not 2, it's 1 by 2. So it's 1 by 2, because don't forget this 1 right here. You have to account for the whole fraction over here. Now similarly for this, cover up this, ask yourself, how do you make this equals to 0? X has to be minus 1. Put that into here, you'll get 1 minus minus 1, which is 1 plus 1, 2. So you'll end up with 1 by 2. So as you can see, we have 1 by 2 in both of the numerators, so we can just take that common. So simply its derivative, do a, well, substitution, not this, just for this integral. Let's say w equals to 1 minus x. That means differentiating it, you get dx is equals to minus dw. So that means overall it's just minus log natural of w, which is 1 minus x. And now this, similarly, it's just log natural of 1 plus x plus c. And here you can use the log property, because you see we have a difference of two log naturals. So ln or ln a minus ln b is equals to ln a by b. So this is 1 by 2, this minus that, so log natural of 1 plus x by 1 minus x plus c. So this is where that comes from. And you can also make a general proof for this standard formula by, well, partial fraction method as well. And for the third method, I'm going to remove these two. So we're going to be doing a substitution. But in fact, it's not any substitution, it's trigonometric. Oh, sorry, not trigonometric. Hyperbolic substitution. Yes, we're going to substitute a hyperbolic function. So the third method, let x be equals to tan hx. Oh, sorry, we can't use x again, so we'll have to use theta. So dx is equals to, differentiating it is the sec x squared theta d theta. Put that in this integral, you'll get sec x squared theta d theta 1 minus tan x squared theta. Now, you may know that 1 plus tan squared theta is equals to sec squared theta. But what about hyperbolic function? Well, here's the thing. If we have sec squared theta minus tan squared theta equals to 1, the difference in the hyperbolic part, which sec x squared theta tan h squared theta equals to 1, the difference here is just plus. Instead of minus, we have a plus. Now, this is not the true for cosec cot relation, because let me just show you, because also cosec squared theta minus cot squared theta is equals to 1. But in the hyperbolic function, you just have to switch these two. So cot h squared theta minus cosec h squared theta equals to 1. So just a little note, these two are the notes. So we're going to be using this row right over here. So we have 1 minus tan h squared theta. So just put that over here. Sec h squared theta becomes 1 minus tan h squared theta. So this is just sec h squared theta d theta by sec h squared theta. And very, very nice. This and that cancels. So we have integration of d theta, which is just theta plus c. And what is theta? Well, simply theta is the hyperbolic tangent inverse of x, tan h inverse x plus c, and that is the 3 ways to solve this integral. And if you learn something new, please like and subscribe. Thank you.